much of that since you will be listening to us doing an activity. You guys can fill it in. What are we going to talk about today? Inverse cosine and inverse tangent. But they're going to have their own weird little restrictions that might not make much sense. Unless some of what we just said resonated. Now, oh man, Precalc teacher failed. Besides the fact that I'm distracting myself with these silly bells. Sine inverse of negative 1/2. I apologize. Sine of negative 1/2 would be drastically different because the angle would be negative 1/2, which would be something weird. Some of you are just going to have to memorize these to figure out where the calculator would go, aka what the inverse function would give out as the one answer, the principal answer, the main answer. Some of you guys would need to memorize these, but just a few of you understand why we chose 2 pi over 3 rather than any of the others. Cosine inverse says, I'm negative in the second quadrant. Yeah, sure. First quadrant and second quadrant, I'll give you those angles. First quadrant would be positive, second quadrant would be negative. So for cosine inverse, it says, hey, if it's a positive number, no stress. I got it, quadrant 1. If it's a negative number, no stress. I got it, quadrant 2. You're only looking in these 2 quadrants for that value. Up there it was negative 1/2. We were looking at 60 degrees. We needed a negative, so we chose the 60-degree one in the second quadrant. Yesterday was sine. I'm going to put these out of order just a little bit so we can see them side by side. Let's go back here. I don't want that page. I want this page. Okay. Yesterday was sine. It had its own little special range. Except with sine, he says, hey, I have positives in the first quadrant. I don't mind those. And I have negatives in the fourth quadrant. It doesn't have negatives again until the third quadrant. That's why that awkward, jumping over thing, we wouldn't have chosen 7 pi over 6. Because that whole second quadrant is off limits, because it's a repeat of quadrant 1. So instead of going all the way over here to the third quadrant, or passing all these answers to get to the third quadrant the other direction, sine says, nah, not 2, not 3, but 1 and 4. If it's a sine inverse of a positive, it's a first quadrant angle. Sine inverse of a negative, it's a negative first quadrant angle, aka fourth quadrant. Once again, I realize that some of you, it's going to be easier just to kind of memorize. I'm looking here for cosine inverse. I'm looking here for sine inverse, but just a few of you, or maybe even more. My more visual ones, my more conceptual ones. It's starting to make a little bit of sense as to why these are what they are. So then, that begs the question, well, what the heck is going on with inverse tangent? We didn't talk about him. I mean, you guys gave me plenty of weird tangents when we were doing unit circle quizzes. I guess I could ask you tangent inverse of negative root 3 over 3. I could write below this, I think. Tangent inverse. Let's think about him. You guys realize I'm only giving you negative numbers, right? Now I am, because all the positives are going to be in what quadrant? 1. So he's allowed to be in quadrant 1, 0 to pi over 2. He's allowed to be in quadrant 1, 0 to pi over 2. He's allowed to be in quadrant 1, but where else is he allowed to be? I kept making that mistake when I was going around the room. I think I messed up on it 2 or 3 times. Maybe you've heard me say it. It's quadrant 3! It's supposed to be positive. I kept on saying quadrant 3 was a negative because sines and cosines and cosecants and secants always are. But who is the one guy who's not negative in the third quadrant? Tangent or cotangent. I made that mistake at least 2 or 3 times. Don't know why. It wasn't on purpose, but good illustration now. tangent is positive in the first quadrant, those are going to be used. But also in the third quadrant. So first quadrant, that's a keeper. Third quadrant, that's a nope. So what do you guys think? Tangent inverse of negative grad 3 over 3. It's not the first or the third. That's where tangent's positive. It's the second or the fourth. We started listing this guy off. What the pi over 6 is. Is it going to be 5 pi over 6? Or negative pi over 6? Or negative 7 pi over 6? Oh, that just got weird. Because tangent works differently than sine or cosine. Sine or cosine have that period of 2 pi. Tangent has that period of pi. It doesn't match up. Or negative. No, it's not 411. What do you guys think? Who's the principal? Or take out one if you think he's definitely not. 11 pi over 6 is not. You're totally right. That like passes through all the quadrants. He's a no because he's past 180. I like it. You're right. You guys thinking of Spencer's explanation for the sine one? 5 pi over 6. Okay, go the bigger positive one, or go the smaller negative. Smaller negative one. Tangent inverse is going to mimic sine inverse. Sorry, that's a point. He's going to go up 90, or he's going to go down 90. His positives are going to be up here in the first quadrant, and his negatives are going to be found down here by going negative in the fourth quadrant. I know, they're doing the like this one. We appreciate JC and all the details for this. So, we have all of our, oh, I didn't even put my boundaries, I'm sorry. Anybody answer why for this one, unlike both of the other ones, I have to keep it open? Why is this dude open, whereas those guys are both closed? A different kind of graph. Tangents are way different than the waves or than the cosecant secants. Why couldn't tangent be at pi over 2 and negative pi over 2? He's doodling. What is he doodling? What does tangent do as he gets closer and closer and closer to pi over 2? It keeps going because what is located at pi over 2? He's going to infinity because at pi over 2 there is an asymptote. There's an asymptote. How can he hit pi over 2? He can't. That's why it's open. What's also at negative pi over 2? Another asymptote. Well, we can't hit that one either. Now, can sine and cosine hit negative pi over 2 and pi over 2?
Yes.
Yes. Can cosine hit 0 and pi? Yes. But tangent can't. Okay, that makes sense. It's never going to be an answer. Well, wait a minute. What would it be in order to be at pi over 2? Am I ready? The one that you, well, you beat me on one, and then you didn't. Undefined. If it was tangent inverse of undefined, how do you put tangent inverse of undefined into your calculator? You don't. Oh, that's right. We wouldn't ever have that as a question. But it could ask you something like, where are the vertical asymptotes of tangent? Hey, that was section 4.6, and we already talked about it because you did it for your graphs. Oop, there it is. Okay. So, here we go. Out of all of the weird inversely graphs, sine has a weird one, cosine's about to have one, and tangent's about to have one too. Let me rearrange my notes because now they're all out of order to show you that stuff. There we go. You guys can keep on taking notes because you might not have gotten that page yet. Out of all of the inverse graphs, sine did that weird like go and take a part of it. Cosine's going to also do that weird cyclic wave but going the other direction thing. And we're only going to be able to take a part of it that doesn't fail the vertical line test. Oh, maybe you also see why we're doing 0 to pi and not going backwards. If we went backwards to the fourth quadrant, it would fail the vertical line test. This is my inverse cosine function passing the vertical line test. But I mean, there's the graph. If you graph it on your calculator, you'd be super confused as to why it's like a little because it's awkward, because it's just a little baby piece. But out of all of them, this is the most important graph right here, at least in calculus and beyond. because he has the entire cycle. Why? Does that fail the vertical line test? No. I might be like, yeah, it does. There's like a vertical line. Okay. It's because my marker is so thick I can't truly show you exactly what's going on. Technically, if I were to zoom in and zoom in and zoom in, and technically, if your calculator did not have that awkward thing called pixels, that makes it only be able to somewhat show me curves. This is going to keep on getting steeper and steeper and steeper and steeper and steeper and steeper and only be vertical at 1 point. Oh, 1 point. How can you have a slope at 1 point? I think that's called calculus. Anyway, tangent inverse gets his entire cycle. So unlike sine and cosine that are stuck in between these negative ones and have all these errors and all this stuff, I think it was it you yesterday, Sid? When we did those inverses of sines and cosines, sometimes those didn't exist, but tangent is going to be just fine because he says, give me anything and everything. I'm good. Okay, so just like sine and cosine, I guess I could show you. What tangent cuts off isn't anything in the cycle, it's all the other cycles. As soon as we start doing other cycles, then it would fail the vertical line test. But, sorry. He gets to have his entire one cycle, which is nice. Y equals arc cosine of x. If you see it, no stress, just think cosine inverse. And then y equals arc tangent of x. If you see it, no stress, just think tan inverse. Same thing as yesterday. All right, someone help Nathan out. It's a struggle. Wake up. Good job. Encourage him to be invested. Angle. Angles go into trig. What comes out? Do you remember from yesterday? Angles go in and what comes out? Ratios. It was a huge struggle yesterday. For some of you, still a struggle today. But angles go in and ratios come out. But for inverse functions, remember it switches. All of these guys, all of the x's, are ratios. Like the ones that you see on the board, the square root of 3 over 3, the 1/2, and the other 1/2, or all the ones that you guys were throwing out. Well, no, you were throwing out angles at me. You were throwing me trig functions and angles, and I was giving you ratios. But as soon as I started flipping the tables on you, doing it backwards, you see what I did there? Backwards? Inverse backwards, undoing. Anyway, I was giving you ratios, and you were supposed to be giving me angles. But here's a big point that I did not make as strongly yesterday as I should have. And I heard it in some of how you guys were describing what you were doing in your calculators. When you write something like cosine inverse of x, how did I just read that? Remember the words I just said? Inverse. How do some of you guys read this? Cosine to the power of -1. What's the struggle? No, but to the -1 power, you flip it. That should be right. Because this notation, whenever you have this with a trig function, it's not to the power of with negative numbers. It was whenever you had like a cosine squared. It's like, yeah, cosine x, cosine cubed. Yeah, cosine. If you have a positive exponent, it's great. Yeah, sure, it's an actual exponent. But as soon as you put in this -1, dude, technically cosine of x is function notation. This is function notation too. It's like f inverse of x. This is the second cosine button on your calculator will never find for you secant. Why? Because it's not a power. That's an inverse notation. Is that awkward? Yeah. Why? If this -1 was a superscript in like almost any other location, what does it mean? This. Then it's one context, it does not. Super awkward. However, context, if you talk to any Bible teacher ever, they're going to say context is crucial, especially Mr. Carmichael, which is a good thing. Because it is. Some people hate the Bible because they're like, it doesn't make sense. I'm like, well, do you look at the context? They hate that, but in math, the exact same thing happens. Did you think about the context? And math is one of those things that everybody agrees is true. Well, you can debate anything. Anyway, can doesn't mean you should. Anyway, there's a life lesson in that. And your worldview and what you see as true and not true. If this is not true, am I going to be kind of a stickler on how you guys read these things off to me in class? And some of you are like, I never talk in class. It's not going to be a problem. Well, A, you all had to talk today in class. And B, it's not really about what you say out loud. It's about what you're thinking in your head. Right? So what do you do when you read it? Second cost button on my calculator? Probably not. Most of you are either thinking cosine to the negative 1 or you're thinking cosine inverse. I need you all to think cosine inverse. Does that make sense? So, who is this not? Secant. Not secant. It's not 1 over cosine, it's not secant. Hey, cool kids, do you want to be amazing? You find me this without your calculator? What is it? Sid has a correct location, but not the correct one principal answer. In the second quadrant, tangent does equal negative 1 at 3 pi over 4. The tangent inverse of negative 1 is not that one. Which one is it? It's not the second quadrant one. It's the fourth quadrant one. So what's the fourth quadrant location of tangent being negative 1? Negative 9. But we're about to give you something like, ready? Tangent. Inverse of 37. Where'd it come from? I have no idea. My question to you is, does it exist? And if it does, what's the only way to find it? Why are you asking? It goes up forever, and so when you flip it, it's going to be able to go over forever. So does it exist? The answer is yes. Would sine inverse have existed? No. Would cosine inverse have existed? No. They're stuck between boing, 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 right? Tangent says, I don't care, but what would it be? You have no way to solve it unless you plug it into the calculator. Oh, better be degree mode. It's 37. That's not 37 degrees. That's not even an angle. That's a ratio of an opposite over an adjacent. That's 37. What does that thing look like? Very tall and very skinny. Anyway, what would the answers be? Someone be in degree mode, someone be in radian mode. Emma, what are you going for? Degree mode. Who's going radian? Sadie, can you be radian? Here's doing tangent inverse of 37 in radian mode. Because remember, either answer is valid. What do you got, Emma? Oh, sorry. What do you got, Sadie?
I have 88.
That's an or. 1.5437. So I'll round that to 4. Good? Cool. Back of the book, I'm pretty sure you're getting both. I would normally ask Nikki if it's looking like that, because I know that she's working on it. If it's Justin and Keeney, I could probably ask you guys too. I'm not surprised if I have to ask you too, but we'll just say the back of the book. I think it has both. Anybody want to give me a quick head nod if you're like, yep, it's given both for the inverse again? Yeah? Keeney's got it. So yeah. So, degree mode or radian mode, you're okay. Either way, you should have an answer in the back that's matching. The reason I was listing off names is I was guessing that most of you have at least started that. The rest of you, I'm not sure I'd be totally positive on that. As far as some names. I could have kept going, but I stopped. Where are we at to finish class today? Some funny stuff. Some funny stuff. What if they start not giving you angles? Remember, we've been doing missing pieces of right triangles. What if they're not giving you an angle, but they're giving you other stuff? Well, good. I agree. So you know Sokotoa Choshikawa up 5 because it's the right triangle. What if they were giving you something like, I don't know, how about 7 and how about 12? I might not be making a nice triangle. How could you solve for the third side? Yeah, you could use a squared plus b squared is c squared. The third side is easy. How could you solve for the two missing angles? I wouldn't do tangent right away because I don't think I'm giving you a great, like, nice, even. That's going to be a decimal answer. If that's a decimal answer, do we want to use a decimal, opposite over adjacent, and a tangent? Not really. That's a perfect. That's a perfect. What's the one trig function that would allow me to keep using the perfect numbers instead of the rounded numbers? Sine. Why sine? Opposite over hypotenuse. So I can use sine inverse of 7 over 12. Now, could you technically have started with, sine of theta is 7 over 12. Let's do sine inverse of both sides. Yeah, that's a thing. You can remember, not divide by sin, but take sine inverse of. There's no dividing the sin to get rid of it. That's not going to help you on your calculator. But sine inverse of both sides will lead you to the correct answer.
So why do you have to use the English again?
Because 7 over 12 is not a unit circle value. So the best you could do is approximate without using some sort of mathematical inverse operation. And the only inverse operation for trig is inverse trig. So I can't use a square root, I can't use an ln or an e, I can't use any of those normal inverses, although those didn't used to be normal to you. The normal inverses were algebra 1, addition and subtraction and multiplication and division, but now you guys know so many more inverses. But the only proper trig inverse is literally trig inverse. Now some of you are like, 7 over 12, it's almost 1/2. Well, almost 1/2. Well, sine is 1/2 at 30-ish, so I think it's kind of like 30-ish, but a little bit higher. Anybody got me a degree for what sine inverse of 7/12 is? I'm not that good. All I know is it's 30-ish. I need somebody to give me. Okay, that's one type of application of inverse trig. You need to get the angles of non-unit circle ratios. But what's another one that you might need to do? In most operations of math, it would be as easy as saying 5 pi over 3. But what's the one word I said that's kind of bugging some of you right now? Let me say it one more time. Justin said 5 pi over 3, and I said, in most places in math, they would just cancel each other out, and you would have your final answer left over. Inverse and regular, square root and squared, cubed and cubed root, addition and subtraction of the same number. They cancel out. So why can't I just say, yes, Justin, great job, 5 pi over 3? Why is this most but not always, and this is a not always? Why is 5 pi over 3 would never come out of an inverse trig? 5 pi over 3, even though it can go into a sine, it will never come out of an inverse. It's allowed to go in, it's just not going to come out the same. Here's, I do illusions. But anyway, coming back. It's going in and it's changing before it comes out. What's it going to become? Where is 5 pi over 3? Okay. I do stuff like that all the time. Fourth quadrant. Got it, Sid. Anybody else beat her? What's the way to get there? First quadrant? No, because it's going to have a totally different, but I can go down. Oh, got it. Negative pi over 3. What's another way of doing it? PEMDAS, good old-fashioned PEMDAS. PEMDAS says to solve, don't you do parentheses first? What is sine of 5 pi over 3? And now you have to think about, oh, stink, negative root 3 over 2 is at what angle again? Psst, psst, psst. It's a pi over 3-ish angle. Oh, that's right. What quadrant again? Psst, psst, psst. Oh, hey, fourth quadrant's good. Just go the other way. So maybe PEMDAS would make it harder than it has to be. But can you go as easy as Sorry. Some angles, when they come in, they come out different. Some, when they go in, they come out the same. What about this one? Yes, I have a smile. Yes, I have not a Lucas smirk, but that's still a little bit one. A lot of people talk about the Lucas smirk. But anyway. What's this one? You can go to your calculator and just get the answer. That's no fun, huh? What's this one? Most of you are thinking it's probably not pi, even though it'd be really nice if it was.
Negative.
This is error.
Whoa! What's not allowed to go inside cosine inverse? Anything bigger than... Remember yesterday you got errors as soon as it got it what? The ratio. That's illegal. If it's illegal, the whole thing's illegal. If the whole thing's illegal, we better just say DNE. Okay. Might lesson that too. But anyway, so what's the last thing? Why is she drawing a triangle? That's weird. All they even gave you was that and this.
Wait, what? Oh.
How did she do that? Why is she wrong? She's erasing it and putting it here.
No.
She made the x the opposite. She made the 2 the hypotenuse. Because what goes into arc trig? Ratios. And what am I looking for to come out? Usually just the angle. But what's out here saying you're not done yet? So really, do I need to be using, I can't use my calculator. It's an x. Guess what this was actually asking for? Not the angle, that's just PEMDAS inside the parentheses. It's asking for a ratio. And guess what you can always do with Pythagorean theorem? Fill in missing sides with a squared plus b squared is c squared in solving, and all I have to do is say, oh, who's the adjacent? If I were you, I'd take a picture on the way out the door, because let's be honest, how many of you are actually going to look at either the video and or the notes tonight? That will be helpful. Bye, guys. Happy nutrition! Happy Thursday! Almost Friday! Almost Sparkle! That's more exciting than the weekend. Bye, guys.